Just for those who have just joined us, welcome to the SOC Masterclass. This is our flagship virtual event that we're doing in collaboration with Microsoft, which focuses on inspiring and upskilling security practitioners to modernize or future-proof their security operations and cyber defense. So in this session, this is a workshop that Tony Velleca, our CEO, and Bruce Roton, our VP of Strategy, will be running. This session will be focusing on how the pillars of a security operations center should be adapting to the threat landscape as the threat landscape changes and as your business changes. So as we know, security teams are being pressured to optimize and future-proof their cyber defense architecture and derive value from new data sources. But how should you prioritize your investments as you evolve your cyber defense architecture? So Tony and Bruce will seek to outline some of the key changes to those fundamental pillars of a SOC and explain how your business should adapt, or how your security operations center should adapt, including things around those drivers for modernization, how to turn some of those drivers into opportunities, how to operationalize cloud native security, turning that nightmare of big data into opportunity and value, looking at how to get security operations aligned to the business, but also touching on the automation side of things. How can humans and bots collaborate to accelerate threat detection and response? So without further ado, I will pass over to yourself, Bruce, to get us started.
Bruce, you there?
Unmute.
I think we can hear you.
Before we jump into how to modernize and why to modernize, I wanted to talk about a few key trends and observations we've had across our customer base and across the broader market. And there are a number of these. We'll start with the fact that targeted detection and automated response are now must-haves. We've seen a trend towards stop looking for things and look for the things that really matter, things that are important, and then try to remediate those as quickly as possible. There's also an unparalleled consolidation in security platform space. We're seeing the mega cap companies like Microsoft, Google, AWS make tremendous investments in security platforms, and we believe that those will be the dominant players in years to come. Cloud adoption is mandating cloud native security, and we'll talk about cloud native versus cloud present and how what those service attributes look like, and also the acceleration of technology velocity. In the last session, they talked a little bit about that, the tools, the variety of tools. It seems there's a new startup security company every couple of weeks or every couple of days with new products and tools out there. Another key area is that business alignment and transparent value is really top priority. The black box service of a security provider, and I want to make note here, every security operations center is really a service provider. It's just a matter of the number of customers you've got. If you've got one customer to service or hundreds. Every SOC is a service provider, and the businesses are looking for value. They want to understand the value, not a message saying this happened, and only get a notification when you think something happened, but show them the real value of the service and make it transparent. Data management is a huge issue, as brought up in the last session. With all the new tools, there's a flood of data. And as you migrate to the cloud, that flood of data becomes even greater. And big data analytics and machine learning, these are now essential capabilities within the SOC. We're going to talk about that significantly more in a bit, but they are core components now of a security operation. And another thing we're seeing is with M&A activity, particularly in the larger enterprises, business unit level security requirements are different for each of the business units. So you need to have tagging, reporting per business unit, and also a roll-up of the global business. Tony, you want to talk about some of the core business drivers and SOC challenges?
Yeah, no, I'd love to. So what we're seeing, UST, the parent company, does work with many Fortune 500 companies. So we looked at the things that are driving changes on IT, or then driving changes on security operations as well. The first one you'll see is most recently with the Ukraine conflict, we got many questions about what does this mean to our security operation, right? And what do we need to do to adapt? So the kinds of attacks, the sophistication of them, a lot of them are focused on malware and ransomware, but the number of attacks that are happening and just the impact is going up, and every day you have to look at it from the threat point of view. This is requiring security operations teams to adapt more quickly. It's not something that you can buy a product for, wait 6 months, and then adapt to a new type of threat. So you have to really handle much of this and how you detect and respond to these types of attacks. The second, and I'm sure we all feel it in this industry, is the skills shortage. The skills shortage is not something that we can solve overnight. Many of the skills you need for advanced attack recognition require that you have many years of experience in security operations, understand IT deep. It's a complex topic. So we can start training people, but more and more we need to look at driving the need for automation. And automation that's smarter, has better, a lot of what security operations do, enriching information so you can come up with a false or negative result, and you know what the action is that you need to take. So getting better data to get better results, and then applying automation is one way, and probably the most important way that we can solve the skills shortage. One of the probably key business drivers we see is the need for companies, and this was accelerated during COVID, the need for companies to start serving their customers on, through touchless applications and different means. This is what we generally refer to as digital transformation. Most of even smaller businesses today need to find ways to serve their customers using IT. So these are mobile apps, they're things, and these digital transformations are driving corporations to move their assets and applications from their data centers into public cloud. This is creating a whole new path for the way you have to look at your data and data coming in, as mentioned in the last session, right? So you have applications now which are becoming more important. They're sitting in the cloud and they're talking to endpoints that are outside your network. So these are new types of problems. And that also means that your core security is moving into the cloud. So this is, you have to follow the data. This is generating for the SOC more and more data, and it's coming from different directions. So as we see the need to handle more data, we also see the need to archive it, and you're finding cloud and things are the best mechanism, have many of these components built in. So it's changing the security landscape there. The fourth is really the complexity of enterprise IT and the security architectures. In some ways, cloud simplifies it, but now you're starting to see smarter endpoints. You're seeing in the future, you're going to see things like self-driving cars, and you're worried about hospitals that have devices on the end. So this complexity is showing up with the need to orchestrate, integrate with more products, and without that orchestration, you just can't train a person to be able to interact with the many different tool sets that you have in your environment. So there are four basic tenets that we see kind of coming out of this, and you'll see these. We'll go through it, and the presentation, Bruce will take you through many of how this relates and are driving changes to the SOC. But the first one is, it was mentioned by Bruce on the first slide that companies, the big companies, Microsoft, Google, AWS, are all investing heavily in cybersecurity. And you're seeing, you're very quickly seeing, acquisitions, and you're seeing companies integrate their systems with this. So we'll talk a little bit about in the presentation why cloud native is not the same as deploying your assets into the cloud, right? Creating a virtual machine and taking the technology, put it into the cloud. You are using the core capabilities of the cloud now to manage the data, to be able to do AI and other pieces, and these are built into the cloud. The second is really around automation. And automation, we believe, is going to show up in terms of how people and bot technology interact with each other. And the reason that's important is that in a security operation environment where you have lots of data and you're looking for patterns, bots do things differently or better. They can see across these patterns and react. So, but the human has to bring the creativity and the interact. So this is going to drive this relationship between human and bots. The other thing, if you go back to the need for training humans, the idea of automation in some of these processes is to also help the human. We can learn from the humans, but the humans can also learn from the bots. So automation and the interaction between bots will be key to this next generation. A third major topic is, I use an old word for this, is just big data. You got the volume, security operations have to deal with it all. The volume, the velocity, the variety, the veracity, and the value of data, right? We have to get through and take this large stream of data and be able to make use of it. So this is the ability to process data effectively, look for patterns, take in different types of data, parse it so that we can look at it, tag it to things like MITRE will be very important. And then finally, hyper agility, the ability to react quickly. This is going to drive processes to build faster means of detection, quicker response capabilities, and to do this in an agile way. So Bruce, back to you.
All right. So let's start with cloud native, and I want to bring up again that it's not the same as cloud deployed. And some of the challenges we see in moving to the cloud. Well, first, migration to cloud is inherent in digital transformation. Tony brought that up. It's an essential part of digital transformation. We see remote workers, and as the workforce is remote, so are the customers. So your business is moving to the cloud, and we believe your security operations needs to move to the cloud as well. Tony brought up the issue of cloud security skills overall, but cloud security skills are really in short supply. And cloud native is not the same as cloud-based, and security teams need the tools to work at scale and efficiency. So some of the great solutions, these first two are really kind of core parts of it, is tight integration with cloud tool sets. I'm talking native cloud storage capability for short-term versus long-term archive, virtualized workload engines, being able to create microservices for work streams, containerization so that you can move between different operating systems, built-in data science and big data analytics services. These are built in to most of the cloud service providers, platforms. Native DevOps tools so that you can create code quickly and create catalogs of components. And that supports the everything as a code, which is huge in the modern SOC in terms of infrastructure as code, being able to deploy things quickly. Immutable infrastructure, meaning that I can take a lockdown secured infrastructure and redeploy it at will over and over again. And if it becomes corrupt, I can just redeploy it again. Being able to have detection and playbook libraries as code is going to be critical. And what we've seen is, in terms of fast, cost-effective onboarding new businesses and new data sources, being able to do everything as code, we've cut the deployment time for a new customer, or in cases of private SOCs, a new business entity, from weeks down to days, and in some cases hours, and new alert sources down from days down to minutes. Another thing to keep in mind is it's resilient, scalable, and it's a metered service by design, which means I know there was a comment about it costing more, but if you architect it properly, it can cost you less because you only use what you need. You don't have to buy the systems. You can do VM instance redeployment and expansion at will. We talked about automation, and the threat velocity is increasing and our responses need to be near instantaneous, especially with ransomware. The idea of having a person detect ransomware and start flipping switches and disabling systems is, well, very 90s, and it doesn't work out very well typically. So the responses need to be instantaneous, and there's a growing gap in skills in the SOC, and the skills requirements are also shifting. The SOC analysts don't just need to be able to do triage and incident management, but they need to be able to write playbooks ad hoc as new things come up. They need to be able to understand how to automate integrations and SOAR capabilities with the infrastructure. They need to be able to expand the SOC capability through innovation, which means that we need a higher level of expertise within the SOC out of the gate. And the security teams are required to create custom components. They need to be able to build things, and they need to be able to do this at scale. So some of the solutions here, automation bots and virtual analysts. Nice thing is that enables nonlinear growth capability in the SOC. Imagine that you're continuing to expand the number of use cases, always expanding the number of use cases, expanding the number of data sources, expanding the number of business units. What we found is that we can flatten that line within our SOC by using automation to keep the analyst count near the same, have their skills increase, and have the bots do repetitious tasks. They're better at that, let's face it. And then the virtual analysts, also as they learn from the best SOC analysts. So we use monitoring to find the shortest path and automation to find that shortest path, train the virtual analyst, and then the virtual analyst can train all of the other analysts to raise everybody's skill level. So it can also monitor the analyst effectiveness and efficiency. If you can redirect in a time of heavy alerts, if you can redirect the alerts to the person most able to efficiently handle them, you can reduce the workload in the SOC and increase efficiency. So by doing monitoring of the analyst effectiveness, funneling the types of alerts to the person who can handle them best, recording their activity and using that as a training mechanism, we found that we can increase the SOC performance by better than 30%. In terms of big data, some of the challenges, I talked about it, the cloud is causing a data flood, along with all the new tools and toys. It's not just volume and velocity, but the variety of data, the new data structures, some of it formatted, some of it not formatted, some of it in a typical log structure, syslog, some of it in JSON, and then the veracity of it and value of it. Being able to analyze what's the value of that data, how useful is it really, where should I store it? So this big data is becoming a challenge, and for many companies, it's really like sitting on a gold mine, because we look at it this way, there's a challenge to having all of that data, but it's a tremendous opportunity if you use it well. There's a lot of things you can do to mine that data to get insights, new insights. So to start with, you need the tools to parse it, standardize it, tag it, sort it for all of the available data sources. And you need analytics to route the highest value data into systems with the shortest response time. So we need to be able to put the high value data into high response data lakes, and the lower value data into long-term searchable data lakes where you can use it for analytics and for queries. Again, a lot of the cloud solutions, most of them, have native data science tools so you can gain insights, find hidden relationships. Are there incidents happening that you didn't know about because you weren't correlating the data? Look for these anomalies. And also looking at ways you can take an alert that comes in and evaluate, is there additional data out there that I didn't know to look at that would have told me if that's a true positive or a false positive? Tag and correlate that data in real time and map it to MITRE schema or to the schemas of the business. And identifying anomalies using cloud-native architectures and cloud-native data discovery. And also be able to feed that analysis into your zero trust architecture to provide context around user actions. In terms of hyper agility, we talked about some of the challenges moving at the speed of business. And there's new detection and response capabilities. We need to develop those, if not weekly, sometimes daily, as new threats emerge. There's new technology deployments. And when you think about cloud, you think about an on-demand service. You can go in and request it, and it's set up in seconds. Well, your customers, the business, expects that from the SOC. So they expect new deployments to be done in hours or days, not weeks or months. And the solutions need to be efficient, resilient, scalable, and focused on the business value. So some of the things we need to do is target the detection and response according to business risk. Develop an agile approach. We'll talk about that in a couple of slides about use case factory management process to quickly develop new use cases. Develop playbooks as microservices and put them in a catalog. Deployment through infrastructures as code, and I talked about that. And then automate the data management so that we can quickly see data flows coming in and manage those data flows into the right repositories for cost-effective usage. And then integrate threat intel directly into use case management. And last but certainly not least, this is really important, use KPIs to drive change and to manage the business. So there's an impact on all of the traditional pillars with these four: cloud native, automation, big data, hyper agility, and they impact people, process, and technology, or flipped in this context, technology, process, and people. And some of the impact we have is around technology, cloud native architecture. We need to deploy data science, machine learning, bots, and automation. There's infrastructure optimization. In other words, are we using the tools that we have effectively? Do they overlap? Can I rationalize some of that? Optimizing the data, taking the data, understanding the data that's coming in and looking at it. Is it used in a use case? Is it really used in detection? Can I put it in long-term storage, or does it need to be in the high-price storage? Making sure that the service is resilient and scalable, and managing component capability and component capacity. In terms of process, we need to develop spend maturity. We'll certainly talk about that, and create a continuous improvement program. We need to automate everything, as Sagi said. Everything is possible. And in DevOps, make everything as code so we can manage it more effectively and certainly manage the value of the service. In terms of people, we've got as Tony talked about, the human and bot integration. We've got to get people trained on new skills, and also performance optimization, monitor their performance, monitor how well they're managing each type of use case so we can direct use cases to the appropriate people. Achieve nonlinear scaling through automation, and also optimize the organizational structure. So let's talk a little bit about technology. And before I turn it over to Tony on architecture, let me go a couple of ideas here. First, in terms of data management, there's some key changes that we're doing in technology around the tool sets for data management, aggregating and pre-correlating tools. In other words, do pre-correlation and create metadata so that the detection rules are now looking at metadata of pre-correlated rules and saving time. Routing and storage optimization tools. There's data value analysis tools, and Sagi talked a little bit about that. The idea of looking at the value of the data, the usefulness of data as it's coming in real time so that you can direct where it's stored. And then automated reporting platforms. In terms of incident management and detection, we've got to automate the triage and the enrichment. We've got to automate the incident and case management. We need to focus more on endpoint solutions for higher fidelity. And you'll see that shift right now to XDR, because looking at raw events and trying to write single event triggered rules is, again, very 90s. Whereas we want to look at high fidelity events from endpoint, from anomaly detection on the network, and from anomaly detection in cloud. In our response area, some key changes: focus on playbook development and community content. There's a tremendous amount of content developed within communities. You see that with Cortex. We're starting to see that with Microsoft and with Google, and have tools to empower the analysts as developers. We want the analysts to be able to create their analysis experience so that we can learn from that. Increase the security infrastructure orchestration, reach out and automate as much of the response as possible. And there's a couple of areas here where these are completely new functions within the SOC for technology: automated cloud behavior analysis, cloud usage and cost monitoring, incident and performance management tools in the cloud, incident discovery like data science, being able to identify incidents that you didn't know existed because you weren't looking for them in the detection rules, and discovering that shortest path to resolution. And then there's OT, ICS, IoT, supply chain monitoring. These are also new areas of focus. Non-traditional data collection and parsing, being able to parse that data appropriately, and tools for anomaly detection and automated supply chain vulnerability detection. We built a little bit of a maturity chart to look at it from a C2M2 model, and I won't go into a great deal of detail on this. I know we're going to be pushing our time limits, but in terms of threat, we started with ad hoc information gathering, moved to threat and intruder hunting, real threat profiling, and now deep, clear dark web threat intel. In terms of risk, asset discovery, and then correlation reporting, and now risk-based use case management, and situational awareness, periodic reviews of events to monitoring logs and correlation rules, and now XDR, cloud native security monitoring with advanced analytics to do that correlation automatically. And the response manual investigation went to automated containment, and now to fully orchestrated response. Tony, I'll turn it over to you for a discussion about the architecture that we've built as an example.
Yeah, this is the importance of an integrated architecture is what's driving much of this this move to cloud native. And you can see here that what's key. If you start at the bottom, getting data into a structure, we used to plumb log sources from on-prem into your SIEM directly. We're finding, looking at the data holistically and moving it into something like a data lake from the beginning, but structuring the data lake in a way, as Sagi mentioned before, parsing the data so you know whether you're running CrowdStrike or Cyber or Defender, you can look at EDR data the same way. Looking at your log retention strategy, the same as your archival strategy, but tying it into your threat hunting. These all become parts of an integrated architecture. So you can see here on the left, you have advanced threat hunting as a service. It's becoming more and more important. Every security operation team needs a threat hunting capability, but they need an environment that allows them to run queries in a timely manner, be able to do these hunts effectively, and bring all the data together. But there are some other advantages as you look at this data lake layer, right? So for example, if you're running an EDR system and you want archival, you might have to pay. And in one scenario with a customer, it was fairly significantly more money to pay them to archive the data for 7, 14, 21 days. By doing this, you actually put all your data together on a similar archival, save yourself money, but also make it much easier to do the threat hunts. As Sagi also mentioned, now you take the data that you need from your data lake through into your SIEM. This could even be multiple SIEMs in some scenarios, but We've standardized really on the Sentinel environment as we go forward. And this is where we can optimize the cost further by putting the data that we need, correlating, aggregating at the data lake level, but keeping all the raw data there. And then you're finding more and more information that gets correlated, enriched within this upper layer, which we call our CyberProof Defense Center platform. This is where you start taking an individual alerts and looking for the threat. Aggregating alerts together so the SOC analyst requires less work, and then automating much of the work here too. So many of the systems today, like EDR systems, give you alerts directly, so you don't need to consume that directly from the SIEM. So all of this, you can see this platform gives you an architecture, but the architecture is very integrated with the various services. So from our point of view, obviously as a supplier, our customers want 24/7 alert monitoring, but they also in large enterprise want help with their managed detection and response and want that collaborative. So you're seeing the need to be able to manage the automation, automate more tied into this architecture, and then bringing it all together in a single view is extremely important. Now, Bruce mentioned before agility. So the use case factory here, if you look on the right, you'll see the use case management type of approaches. All of this is code. So it's DevOps, whether it's infrastructure or whether it's playbooks or rules, but a lot of this needs to be built quickly and deployed very quickly. So you can see this becomes more like a function that somebody has to do and then deploy. And then finally, if you look at threat intelligence here on the top left-hand side, you'll see that this is also important to integrate this. These are external sources, but these need to be, as a service, they're proactive. They also need to be integrated in so that they create alerts. They may be correlated with other alerts and then fed. So anyway, it's very important to understand the entire architecture, not just the components of an architecture and how it works together with the services or the people working in the team. Back to you, Bruce.
I would just add that I know this looks really complicated, but we built it over the course of several years. And the core point here is that, yeah, it is complicated, but it's also tightly integrated. All of these parts work together. And we built this over several years, and this is battle tested. We've got this deployed with some of the largest organizations in the world. And it is working effectively and efficiently. But again, it took a few years to build it. So we'll talk a little bit about the next set process. Some things I think are worth asking. So when you think about the processes, are the alerts and incidents managed consistently? Are they optimized and automated? Obviously, automated is the best way to go. But if we can look at the shortest path, we found again that we can optimize that and save about 30% in SOC utilization just by optimizing the alert path. Are you relying on heroes, or do you have a team of high performers? How are you actually measuring their performance? And is the data collected actually used? We find a lot of organizations collect massive amounts of data, and then they start combing through the data saying, well, what's here? What could I use? That's a backwards approach. I'll talk about that more in the next minute or two. So can you manage that data better? And can you prove that the SOC is reducing risk? Are you really aligned to risk, and can you measure that through performance reports? Do the infrastructure components complement and support each other, or do they overlap? Are there gaps? Do you have a continuous improvement program? Is there a roadmap for continuous improvement? And is it operating at speed, at the speed of the business? And last, but certainly not least, and really important, how well do you communicate and collaborate with the business so that they can truly see the value of your operation? Some of the things that have changed in the process area, obviously use case development needs to be highly aligned to business risk. And we created a factory model that I'll show you on the next slide. It needs to be repeatable, optimized for content development, and also content deployment. And playbooks and workflows, these need to be microservice component driven so that you can take pieces of them, mix and match them, and rapidly create new playbooks. Most of it needs to be a hybrid sourcing, both internal and from the community. And it needs to be highly automated. So your analysts need to be able to help with that automation. In terms of the infrastructure management, multi-cloud integration is key. Being able to pull data from multiple clouds. In fact, being able to have a single SIM or detection agent, XDR, pull from multiple clouds at the same time, so you don't have to move the data into one place, is going to be key. And then continuous optimization and cost management of the data and of the infrastructure. Again, going back to one of the comments we had earlier about the cost, we found a way actually in one of our customers to cut the cost of data management from over $10 million a year to under $500,000 a year, simply by optimizing the data flows. And then there are those new processes that didn't exist before that need to exist now in data management, onboarding and optimization, looking at the value analysis of that data, looking at multi-cloud data lake management, and innovation management, continuous improvement, idea incubation processes. Some of your best ideas are going to come from your SOC analysts, but what happens to those ideas? Do they have a place to elevate them, and do they have a place to incubate those? And then data science management. In looking at the use case factory, we talked about that. We needed a new approach to build and maintain at scale. We had over 1,500 use cases that we had to build and maintain in less than a year and a half. We know that they're more valuable when they're based on business risk. And we also need to manage the deprecation of use cases and also the tuning of them. So we started with a risk-based model, looking at the risk assessment, doing threat modeling, scenario mapping, and then looking at the use case requirements. So we built essentially a as needed or desired state. And then we can map that to what are the current capabilities? What existing use cases do we have? What's the MITRE gap analysis? What log sources do we have? Instead of taking the approach of what's in the logs, take the approach of what am I looking for? Now, do I have it in my log sources and data analytics? And then create that risk coverage map of where I need to go based on risk management. And I can do the rule detection development, playbook, integration, responses, dashboards, do the testing, and then ensure that I have continuous improvement, deprecate the ones that aren't needed anymore, and tune the ones that still are, and have an entire use case management library. I think we have over 1,600 different use cases in our library, and as we bring in public sources, we expect to have thousands more. Manage the changes to the use cases and to the existing reports and dashboards, filter them, and report on their effectiveness. Some of the value here is that we wanted to ensure that the use cases are well aligned to the business risk. And that's not, when we talk about that, that's not coverage in the context of framework coverage. I'm talking about how comprehensive is the coverage in terms of the business risk, not of a framework. Looking at, am I aligned to 27002 or NIST 853 is nice, or am I aligned to MITRE? Nice. But does that really tell me, if I'm managing a use case and spending effort on a use case that is something that I will never encounter, that's not as effective. Also, how efficient are the tools and processes at achieving those? Are the tools complementary? So one of the things we wanted to develop is a mechanism for going from business risk all the way down to the actions of any analyst in the SOC, and be able to map those end to end and say, this business risk links to this cyber risk, links to a negative outcome, a scenario, and the techniques that are used, and the specific actions in the SOC that are being used to mitigate that. In terms of people management, there are some changes in the SOC and in the organization. First off, in the level 1 SOC, 80% of that should be bot and only 20% human. So we need to change that model. Right now, typically it's 90% human and 10% automated. But we need to flip that equation. We need to make it more incident focused, not alerts, not events, but incidents, which means I need machine learning based performance management, and I also need machine learning based grouping of incidents. Need automated tuning. So as we see that items are listed as false positive, we need to automate that process of understanding why they were false positive and automatically correct the tuning mechanism so that we don't encounter it again. We need to start with higher L1 skill sets. Looking at L2, the L2 folks need to be able to use machine learning to do root cause analysis, as opposed to simple investigations. And they need to be engaged with the use case factory management and develop new content through graphical editors. So we're changing the function of L2 and making them more playbook editors and playbook creators. And they need to be able to understand the data requirements. So our L2 analysts should be looking at what use cases do we want to develop, evaluating what data we need, and then looking at the infrastructure to assess whether or not it's capable of producing that data. In the L3 area, one of the things we're changing is threat modeling, having the L3 analysts actually do advanced threat modeling to anticipate use cases, and also doing attack surface analysis and attack surface discovery, which is key, especially as you move into the cloud and anybody in the company can go spin up a new VM or spin up a new data store. Finding those and ensuring that you know where all of your data is going to be key. And also doing red team automation. We need to be able to see alerts come in, and then as we detect potential threats, be able to test those out by automating a red team attack through that scenario to see if it would be effective. And then, of course, aligning that with advanced threat intelligence. And then these last two are, again, a couple of new areas for people. Infrastructure and data management. Data management is going to be a key process. Infrastructure is code development and the cloud security architecture, and special services as well, like a business management interface, having people from the SOC who specialize in working with the business leaders to identify their business risk. And then transformation services. One of the things we saw as kind of a lesson learned was that it was a little more challenging than we initially thought to move 500 rules from a legacy system into the cloud. And also moving the tools into the cloud. So transformation services become a key element in the SOC. And then security data science capability is also a key element within the SOC.
Thanks, Bruce. I just wanted to quickly just cut in before you finish this session, just to remind everyone that we are running a quiz after this to test everyone's knowledge on what we've just gone through. So I hope everyone's been listening, because we'll be testing your knowledge very soon after this slide. So please have a look at the chat and you'll see the link there. You can go directly to it, or you can go to kahoot.it and then type in the pin 8245793, which is there in the chat again. All right. Thank you, Bruce. Please carry on.
Thanks. So when we look at the new functions within the SOC, there's some new skills as well. In terms of security monitoring, the new skills are use case management and alert enrichment methods. Being able to decipher the business risk and turn it into a use case, and automation of incident discovery. And again, not talking about automation of alerts, but automation of incident discovery, so that I can take alerts and aggregate them into incidents, and also be able to reach out into that data lake and do additional queries to identify whether or not they are true incidents. Alignment of business risk. Our folks in security monitoring need to understand the business. So I'll give you a real quick example. I was working with a company a year or two ago where I asked them, well, where's your data? And they said it's in our data center. They're a manufacturing company. They have manufacturing sites all over the world. I said, well, how are the manufacturing sites manufacturing those products if you're not sending them the design data? Well, I guess we are sending it to all the factories. Well, then you have data in a lot of places that you didn't know about. How does this work? And they weren't really aligned to how the business works and where their data is. So our security monitoring team in the SOC has to have a deep knowledge of the business. They also have to have a deep knowledge of attack scenarios and MITRE alignment. In terms of incident response, they need to be able to do automation scripting so that we can make a high-speed response. Again, they have to be in near real time. And deep understanding of that infrastructure. If they don't understand the organization's infrastructure, then they don't know how to automate a response using that infrastructure and those tools effectively. And then threat modeling and deep scenario analysis. Seeing an alert, most alerts you'll see, they talk about some isolated thing that happened, but not the outcome. We need to be able to map that to a scenario and an outcome. And threat intelligence is becoming much more important, and we need to be able to do machine learning-based threat intelligence and intruder hunting. Conversion of those new indicators of compromise into actual use cases. And then prevention management. Vulnerability management is changing. It now includes attack surface discovery and attack surface analysis. And it needs to be integrated with attack simulation tools and also deception techniques. If I see that someone's trying to attack with a particular type of tool, I want to know all the other tools that those attack groups use, and then set up a deception network that can entrap them. And then being able to look at vulnerability management in cloud environments is very different than on-prem. And digital forensics, that's a whole different world. Cloud integrated forensics methods and best practices are very different than on-prem. Also understanding what you will and won't have access to. And cloud-based audit, e-discovery. And then partnership with DevSecOps. Make sure you design your applications for evidence collection. And then again, those are the changing roles, but then there's all new roles within the SOC as well, all new skills. Security engineering, custom parsers, and data management. Don't rely on the vendor to create necessarily the parsers into your SIEM. And CI/CD management, being able to do agile development and continuous development. Infrastructure, well, everything as code, and automation engineering, being able to have a team of folks that can automate and integrate with the infrastructure. And innovation, data science tools, data science algorithm development, and infrastructure and process optimization analysis. What's that shortest path to resolution? And then data engineering and optimization, and of course, technology research and planning, because there's always new tools becoming available. And with that, it's time for your quiz.
Thank you, Bruce. Thank you, Tony.